Hi, my name is Irvine, and this is
Jackie.
and we have one more person.
Oh, hi there! I'm Tanika, and we are doing a video about experiment 3, and this is on how to demonstrate how to calculate empirical formula of a count. Oops, sorry. This is used by using the law of definite proportions, which states that mole ratios of elements in a compound will be a small whole number. Oh yeah! Boom!
Okay, now we're gonna do the procedure part, which I don't know what to say.
Just say it. Not anything but just say it.
Okay, so the most important part of this experiment is to wear your goggles. If you do
Sad
not
about
wear your
it.
goggles, the whole experiment could be screwed up. So the next step in this experiment is to measure the crucible without the top, like measure the mass, and get the mass of the crucible. Okay, but anyways, after measuring the crucible, we have two samples. One was 23.0 grams. The other was 23.7 grams. After measuring the crucible, you now have to measure your crucible with your hydrated sample of copper chloride. Our first sample was 20, what did I say? 24? 24? 20, what was it? 24.4?
Yeah,
24.44 grams.
Yeah.
The next sample was 24.8 grams.
I know.
I am not. Okay, anyway, what's next? Oh. After heating your sample, make sure to let the sample cool for approximately 2 minutes. Then you get to measure your sample. The measurements are: after heating the copper chloride, you now have an anhydrous sample instead of a hydrated sample because you lost the water into the water. The mass of the crucible with the anhydrous sample is 24.18 grams and 24.4.
So yeah, I'm gonna take over. So the next thing to do when all that is done after when you add what?
6 molarity.
Well, you first of all take the substance which is in a crucible into. So when that is in there, you add probably a little amount of distilled water. Well, I don't. Well, you rinse the substance from the crucible with water to
8 milliliters.
Also, when that is done, you have to use aluminium. Well, I think the main purpose, I don't know the main purpose of using aluminium in this experiment. What's the purpose? Okay, aluminium, then when that has been turned into the beaker, you get a little amount of aluminium. Well, our chemistry class had 20 centimeters. Well, I don't know. But we didn't use that, so we just used any amount. And I'm sorry that it's upside down. I don't know why we used like that. Sorry,
I think it'll flip back.
Oh, okay. So after doing that, we found out that the solution was unclear. So we added 6
Molarity.
6M, which stands for
Big M.
Big M, which stands for molarity of HCl. And you have to be careful with HCl because it's very reactive. So you just want to be careful not to burn it. So that is why you have to wear
Your goggles.
goggles
because
and
it's
your
not
apron,
my
and
go bar.
please have gloves. If your teacher doesn't give you gloves, make sure you get them. So then after that, completely made the aluminium dissolve completely, and made it like, and it had like, and it formed a clear solution. So after that, you set up the filtration. The best filtration to use is a vacuum filtration with a whatever something. What is it?
Buchner.
With a Buchner filter funnel. So you use a Buchner funnel and set up a vacuum filtration. I think that's the best one. Well, sometimes to pass time, you just do the gravity filtration. So when that is done, you like let it. If you know how to set that, let the water run for like 5 minutes and let it filter properly. So when you feel the aluminium, the HCl and aluminum that has been dissolved in the substance has been filtered completely. Yeah, so when that is done, the only
Right.
thing left. So after the filtration, the only thing left in the filter paper is the copper because the HCl and aluminum were completely dissolved, were completely out of the, will go out because they're liquid. You partially the filter paper because they're in a liquid and they're in a solution form that's in a liquid form. Sorry. Okay, so after the copper was left out, you just let that dry and make sure your copper is completely dry to be able to get the mass of that because if it's not dry then you won't be able to weigh it and you're also weighing that with the little amount of water in it and it to be liquid. So when that is dry completely, you take the mass of that and you should probably first of all before you do that you have to get the mass of the filter paper because you will use the filter paper to get the copper and the mass of the filter paper was given after that you have to calculate the mass of the filter paper and the copper together. So when you get that, that's how you get the mass of copper. So when that is done, I'll give you the values for that.
Like point zero. Now we're going to talk about some things that you have to calculate. Your hydrated sample. With your hydrated sample, you have to take the mass of the crucible with the hydrated
No, that
sample minus the mass of the crucible by itself. So if you take 24.44 grams minus 23.0 grams, you get 1.44 grams. For this one, if you take 24.8 grams minus 23.7 grams, you get 1.1 grams.
Yeah.
To get your anhydrous sample, you take the crucible with the anhydrous sample minus the crucible by itself. And you get 1.18 grams. And what is that number? For the mass of this anhydrous sample, you get 0.74 grams.
Yeah.
Oh, now you have to measure the mass of the filter paper. The mass of the filter paper is 4.8 grams. Okay, so the mass of the first sample of copper in the watch glass is 31.86 grams. The second sample plus the watch glass is what? 43.68 grams. So, to calculate the mass of the copper, you take the mass of the copper plus the watch glass minus the mass of just the watch glass. So, for this one, you get 1.1 grams. Sorry. 1.01 grams. For the second one, you get 0.2 grams. Obviously, something weird has happened because this sample is much larger than this sample. So one of these was probably done incorrectly.
Let's find the molar mass of all of them. So
Oh, it doesn't help.
exactly, just have to study. So the mole of copper at Cu will be equals to the mass of copper over the molar mass. The molar mass of copper. Get the mole of copper. We have to get the mass of copper over the molar mass of copper.
Molar mass of copper is
And the molar mass of copper through the periodic table is 63.55
3.55 grams.
grams per mole. And the mass which was gotten here was 0.2 grams. So obviously the grams will cancel out. And this, using your calculator, sorry. And this using your calculator will be 0.2 divided by 63.55. And you get the mole of copper to be 3.147 mole approximately. So this is the mole of copper. And of chlorine, we have to divide the mass, which just got was 0.54 over the molar mass. And mind you, the molar mass, we should know this through the periodic table, the molar mass of chlorine is 35.45 grams per mole. I feel every chemistry student should have set the back of their mind because you will definitely work with the molar mass of chlorine. But in probably all chemicals, the molar chlorine is equals to the grams of chlorine, which is 0.54 grams over the molar mass, which is 35.45 grams per mole. And the grams are pentagrams. So if I have to look for that, that would be 0.54 divided by 35.45. And that would give you 0.015 approximately. So now we have the mole of each of them. And now we need to find the empirical formula. So this is practically what we have. And using the law of definite proportion, we have Cu is directly proportional to C of the mole. So N is mole. The mole of copper is directly proportional to the mole of chlorine. And the mole of copper is 3.147 moles. 0.01.
Okay, so for this right here, to get it to be in the empirical formula, you need to get this number 3.147 and this number 0.015. The whole numbers. Considering how small this number is, it's very difficult. So, in this case, you can't really get the empirical formula because this number is so small. It would not be plausible. So, in this case, you can't figure out the empirical formula. For another case, say you had 1.5 moles of copper or 0.5 moles of chlorine, you could change both of these to a whole number by multiplying by 2. So, this would become 3 moles of copper, and this would become 1 mole of chlorine. So if you write this in the empirical formula, you would have Cu3Cl1, which you don't write. Ta-da!